Hi guys, welcome to Simple Programming. In this video, let us see how to containerize your Spring Boot application using Docker. I will be doing a tutorial series on Docker and we shall look at things like Docker Compose, Swarms, etc. But for this example, let me quickly give you an idea about containerization and will help you to quick start your containerization journey with Docker. Now, what is meant by containerization with Docker? Let me give you a simple use case for better understanding. Let us say you have a web server, database, messaging server, etc. There are different software components in your application, and you have to ship your application to multiple centers and make it run in those platforms. For this, you have to make sure that all these services are supported by the underlying OS and hardware. Application built on one operating system cannot be guaranteed to run in another operating system. Some services might work in one version and others might require a different version. Additionally, you have to take care of the dependency versions. This would be a very tedious work. Do you see the problem here? Lot of work needs to be done to make a software work in multiple environments. Now Docker comes to our rescue. Docker is a platform where you can build, ship, and run distributed applications in multiple environments like it can be your laptop, data center, virtual machines, and in cloud with less or zero groundwork. Before we start, make sure that you have registered and created an account in the Docker Hub. For this example, I have created a Spring Boot application. It is a very simple example where I have created a REST controller which has a get mapping and it is going to return a string Spring Boot Docker example. Here's the pom.xml of my application. There is no fancy stuff, just the regular Spring Boot starter web dependency in it. To containerize my Spring Boot application, I'm going to use a Docker file. What is a Docker file? It is nothing but a file that contains instructions and arguments that is required to build and run a program. You can do all these stuffs directly in the command line, but that would be manual work. So you can simplify that by using a Docker file and you can also save it in your repository for future usage. Here's my Docker file and there are 4 commands in it. From OpenJDK, get the latest version, add the jar file inside the target folder and give a name as app.jar and the entry point is java-jar, the jar file that you need to execute. And if you want to expose it with the custom port, right, you can do it here. It is going to be 8080. So it is a very simple example. What is meant by this OpenJDK? Well, it is nothing but your actual Java. The Java is currently deprecated and the OpenJDK is the Java version that you use inside your container. So everything that you use in your application resides inside a container. If you want to use Cassandra, if you want to use MongoDB, if you want to use some messaging broker or service, everything you use within the container and these elements are available in the Docker Hub. Here is my Docker Hub homepage and I'm going to search for Java. So the first link is the Java official. Click on this and you could see here it has been deprecated. The image is officially deprecated in the favor of OpenJDK image. So click on this OpenJDK and this is the actual Java that you are going to use within your container. So they are already given you steps how to incorporate this into your containers. So let's say you want to use Cassandra. Cassandra repository is already available. You can use it to start a Cassandra server instance in a container and then you can make use of referring it from a different container. So all the setup related activities are eradicated with the use of containers. For example, let's say you want to use Redis. Redis is available. You can use it as a message broker. Let us quickly build this project and then let us go to our command line interface and let us try to write some commands to build this Docker image and then use it. To jumpstart using Docker, you need to understand few basic commands. So the first command is docker-v. It will give you the version of the Docker. Then Docker login. I'm already logged in, so it is again authenticating to keep the session alive. If you are not logged in, it will ask you for the username and password that you gave in the Docker Hub. You can log in here and your console will be automatically logged in and incorporated into Docker. Then Docker ps-a. This will give you the list of containers that are currently running. Then you have the Docker images. What are the different images that you have downloaded from the Docker repository and what are the images that you created in your local. Then you have the Docker build. You have Docker run to run an application. You have Docker push to push an image to the Docker repository. Then you have Docker remove image. So these are the commands that you will take a look at in this tutorial. In case if you are not using a Docker file, this is how you would be writing all these commands. Docker build target slash. You'll be giving out the the jar here, and then you will mention all the dependencies, the commands, everything. But with the usage of Docker file, you don't have to do all these things. When using Docker file, it simplifies the overall process. You would be doing a Docker build. You can directly give the name, or if you don't give a name, Docker will automatically create a name for you, a funny name for your image. If you want to give a name, give a -t, that is a tag. Given your username to uniquely identify your image and give the image name that you want to give, and followed by a dot to include everything. The build process has been successfully completed. You could see here the steps that we mentioned in the Docker file are mentioned here as step 1, step 2, step 3 and step 4. So the Docker build is done. Now let us take a look at our Docker images. You could see here a new image has been created 14 seconds ago. That is the image that we created from the Spring Boot project. Let's go and run this. In order to run this, I'm going to do a port mapping. That is, my internal port is 8080, but I have a Jenkins running in my local machine in 8080. So there will be a conflict. So I'm going to map my internal port 8080 to my laptop's 8000 port, and then I'm going to run this app. My application is up and running. Let's go and let's try to access this. Alright, so our application is working fine inside the Docker. I'm able to access my application in the port 8000 and I'm getting a response from my Spring Boot application. Let's quickly go back to our console. Now you can see here the application is running in the console. What if I want to run it as a background process? You can do it using Docker. So let me quickly terminate this, and what I'm going to do is in my Docker run command I'm going to add a -d, and the application is running in the background. Let us take a look at our container. To access your container, you have to use the docker ps-a. You could see here the Docker container is running in the background, and here is the previous Docker images that I executed. Now our application is up and running in our local, but in order to have easy access on the repository, you need to push it to the Docker Hub. Let us quickly take a look at how to push to Docker Hub. You have to use the command docker push, give the name of your image. Alright, looks like the push has been successfully done. Let us quickly take a look into our Docker Hub repository to check whether our application is uploaded or not. Let's go back to the browser. Let me do a quick refresh. Cool. So our application is now uploaded to our Docker repository. Now you can use this Docker repository and pull this application in any environment you want. You can either use it in AWS, or you can use it in Azure cloud, or you can use it in your laptop, or you can use it in any virtual machines or any data centers, you can easily pull this information and then run your application just like that. Now, do you see how Docker makes packaging and deployment processes easy for you? Let us quickly go to the console and let us delete all the containers and images that we created. So in order to delete a container, you have to use the Docker RM and give the three first three letters of the container ID. So I need to stop the container. So let me quickly stop the container. The container has been stopped, and let's remove this now. You don't have to give the full name of the container ID or your image name. You can directly use just the three letters of the container ID, and our Docker will recognize and delete it for you. Let's go to our images. Use the Docker images command, and you could see here my image is there. I'm going to remove this. To remove an image, you have to use RMI. To remove a container, you have to use RM. Let's quickly delete this. Okay, the image has been deleted. With this, we come to the conclusion of our Spring Boot Docker containerization video. I hope that you really enjoyed this video. Please subscribe for more such videos. Thank you.